Hi guys, Audrey here, and this is a JAC capsule on factoring. In this video, we're going to be talking about a method for factoring non-monic quadratic polynomials. So remember, monic means that the leading term is multiplied by 1. So non-monic will mean that the leading term is multiplied by something other than 1. Quadratic means that the highest power is 2. So we will be factoring these non-monic quadratic polynomials. Let's get to it. So in this video, we'll be finding one of many methods for factoring these non-monic quadratic polynomials. So we see the polynomial ax squared plus bx plus c. In this case, that a is not equal to 1 because this is non-monic. So note that this method also works for monic polynomials. So what we want here is two numbers. Let's call them m and n. And we want it such that their product m times n is equal to a times c. In other words, we want to find a number whose product is equal to the coefficient of x squared times the constant term, and whose sum m plus n is just equal to b. So in other words, the product is going to be the multiplication of those two, and the sum is just that coefficient of the x term. Then what we're going to do with that m and n, once we found it, because its sum is b, we can actually separate bx into ax squared. So we're separating that bx into mx plus nx, and then plus c. And then what we're going to do from here is factor by grouping. So we'll separate each of these two things into a group of two terms and factor out the greatest common factor, then pull that out at the end. So if you're uncomfortable with factoring by grouping, make sure that you check out the factoring by grouping video. Otherwise, we're going to see how to do it with these non-monic quadratics. So from here, factor by grouping. Now, the best way to see how this works is to actually just factor a polynomial. So here we're going to be factoring the polynomial 12x squared plus 16x plus 5. So the two numbers that we want are m and n. We want for that product, m times n, to equal to 12 times 5, which is 60, and we want for m plus n to equal to 16. Now, if you think about it, it's pretty easy to see that these two numbers are therefore 10 and 6. So m is equal to 10 and n is equal to 6. But same as with the monic quadratics, if you don't see that right away, not a big deal. You can go and you can start by thinking of 60 divided by 1. 1 times 60 is equal to 60, but 1 plus 60 is 61, which is definitely not 16. Then 60 divided by 2 is 30. So 2 times 30 is 60, but 2 plus 30 is equal to 32, which again is not what we want. So then we'll move on to 3. 60 divided by 3 is 20, so 3 times 20 is 60, but 3 plus 20 is equal to 23. So we're still not there. 60 is also divisible by 4, so 4 times 15 is equal to 60, but 15 plus 4, or 4 plus 15, is equal to 19. We're getting closer. That 19 is closer to 16, but we're still not there. 5 times 12 is equal to 60, but 5 plus 12 is equal to 17, not quite yet. And then finally we're at 6. 6 times 10 is equal to 60, and 6 plus 10 is equal to 16. So again, you don't have to do this. This is just if you're struggling to find the value. And in this case, we finally got there with the 6 times 10. All right, let's get to factoring. So now that we have our two numbers, we are going to separate that 16x into 10x plus 6x. And then we're going to factor this by grouping. So I'm separating this now into two groups of two, and I want to find the greatest common factor from each group. Well, I can think of 12 as 2 times 3 times 3, and 6 is 2 times 3, and 10 is 2 times 5. So in my first group, I can see that the GCF is just 2x. And in the second group, there is no GCF. So there's nothing to factor out. So we're going to factor that 2x out of the first group to get 2x times 6x plus 5. And then we're going to leave the second group in parentheses. There was nothing to factor out, 6x plus 5. And we'll notice that the 6x plus 5 that showed up is the same in both of those terms. So great news, that's what we wanted. Now we're going to factor it out. So we get that 6x plus 5 times 2x plus 1. Remember when we're factoring out something and that something is the entire term, there's always just a 1 left over. It can also be helpful to think of this as 1 times 6x plus 5. And that is my final answer. But I want to make it clear that here I picked 10x plus 6x, but it turns out that order does not matter. I could have picked 6x plus 10x and still gotten to the correct answer. So mx plus nx or nx plus mx, order doesn't matter. And with that said, let's just see how it would work if we switched the order. So we have 12x squared plus 6x plus 10x plus 5 that we're now separating into those two groups. And in the first group, we can see that the GCF is 6x. And in the second group, we can see that the GCF is 5. So we'll factor out those greatest common factors to get 6x times 2x plus 1 plus 5 times 2x plus 1. And now that factor in common is the 2x plus 1. So we factor it out to get 2x plus 1 times 6x plus 5, which is the same thing that we got before. All right, so that is factoring by grouping to factor non-monic quadratic polynomials. That's all. Bye, guys.